1. Task introduction. The AGV, automated guided vehicle, primarily operates in coordination with 6-axis and 4-axis robots to complete the warehousing of finished workpieces. The AGV receives commands from the master control system via Wi-Fi. It intelligently recognizes the map, sets its route, and automatically carries out the transportation of finished workpieces. After completing the transport task, it automatically returns to its standby position and sends a completion signal back to the master control system. 2. Learning objectives. Knowledge objectives. Understand the functions of the AGV. Master the configurations and setup procedures required for proper AGV operation in the intelligent manufacturing production line. Skill objectives. Be able to proficiently configure the AGV. Be able to correctly perform every step involved in starting up an industrial manufacturing production line. Caliber objectives. Develop a spirit of teamwork and collaboration. Foster a work ethic grounded in rigor and standardization. Build strong safety awareness to ensure the safety of personnel and equipment. 3. Guiding questions. 1. What are the functions of the AGV? The functions of the AGV include navigation and localization, path planning and control, motion control, task scheduling and communication, safety protection and obstacle avoidance, status monitoring and feedback, remote monitoring, and charging management. 2. What configurations are required to ensure proper AGV operation? To ensure the AGV functions correctly, the following configurations are required: route editing, initial position setup, map scanning, and automated task configuration. 4. Knowledge description. 1. AGV functions. 1. Navigation and localization. Navigation methods. AGVs typically employ one or more navigation technologies, such as magnetic tape navigation, QR code navigation, laser navigation, SLAM simultaneous localization, and mapping navigation or visual navigation. These technologies enable the AGV to determine its location within the working environment and travel along a predefined path. Positioning sensors. These include LiDAR, cameras, magnetic sensors, encoders, etc., which allow the AGV to perceive its position relative to the surrounding environment in real time, achieving precise localization. 2. Path planning and control. Path planning. Based on a predefined map, task instructions, or real-time environmental data, the AGV control system calculates the optimal travel path to avoid obstacles and meet task requirements. 3. Motion control. Through drive motors such as servo motors, the AGV controls its driving or steering wheels to perform movements such as forward, backward, and turning. The control system precisely adjusts motor speed and steering angle according to navigation data and path planning instructions to ensure accurate travel along the planned path. 4. Task scheduling and communication. Task reception. The AGV receives task instructions from the central control system or host computer via wireless communication. For example, Wi-Fi, Bluetooth, 4G, 5G, or wire connections. Tasks may include transporting goods to a designated location or returning to a charging station. Task execution. Based on received instructions, the AGV performs sequential operations such as pickup, transport, and unloading. During this process, the AGV may interact with external devices, for example, shelves, conveyors, elevators, via I/O interfaces or communication protocols to exchange information. 5. Safety protection and obstacle avoidance. Safety sensors. AGVs are equipped with various safety sensors such as LiDAR, ultrasonic sensors, photoelectric switches, and bumper strips. These sensors continuously monitor the surrounding environment, detect obstacles, and trigger avoidance actions. Safety strategies. When obstacles or potential risks are detected, the AGV executes predefined safety strategies, such as slowing down, stopping, rerouting, or issuing alerts to ensure the safety of personnel and equipment. 6. Status monitoring and feedback. Status monitoring. The AGV continuously monitors its internal status, such as battery level, motor temperature, and fault indicators, and reports this information to the control system. 7. Remote monitoring. Through network connectivity, the central control system or a remote monitoring platform can access real-time data on the AGV's position, operational status, and task progress. This enables effective remote management and fault diagnosis. 8. Charging management. Automatic charging. When the AGV's battery level drops below a preset threshold, it will automatically locate and dock with a charging station. Once fully charged, it resumes its assigned tasks. Battery management. A battery management system, BMS, monitors the condition of the battery, ensuring its health and extending its service life. 2. AGV operation analysis. 1. Route editing for the AGV. 1. Open the menu bar, scroll to find Edit Route, then click Add Route to create a new route. Enter the route name and confirm. 2. Click Edit Route to begin editing the route. First, click Fix Point to set the starting position of the route, then drag the map to determine the direction of the starting point. Continue setting the direction of each turning point. 3. Click Show Route to display the route you just edited. First, click Upload to confirm and update the current route. Then click Refresh, select the newly created route, and click Show Route. The route will now appear on the screen. 4. Click the Add Reverse Route button in the upper right corner and confirm. Then click Upload to update the current route to the AGV, and finally click Refresh to complete the addition of the reverse route. 5. Set the route speed. Select a route, and 10 position points will appear. Click Modify all travel speeds in the upper right corner, range 0 to 1.2. Click Upload again to update the data to the AGV, then click Refresh to complete the speed setting. Finally, select the route and choose Run to operate the AGV. 2. Initialization setup for the AGV. Click Set Map, then choose a map and click Start Navigation. Observe whether the red laser overlaps with the map's boundary lines. If it does not align, click Initialize in the menu bar, then drag the map to adjust the AGV's orientation and position, informing the vehicle of its initial position. 3. Map scanning setup for the AGV. 1. Open the software, click on the login box, and switch to Use Scan Address. 2. Click the map icon and wait for it to load. Select the corresponding IP address for the map to be created and click the Scan Map icon to wake up the AGV. You should hear an alert sound. 3. Click the menu icon, select Create Map, and then click Start Mapping to begin scanning the environment. 4. Expand the remote control panel, switch the toggle to On, and uncheck collision avoidance. 5. The AGV will now begin scanning the front area. Then, use the remote control panel to scan the area behind. 6. After scanning is complete, click Create Map, enter a map name, and save it. Note: the map name must not contain Chinese characters or special symbols. This completes the map scanning process. 4. Automatic task setup for the AGV. 1. Click the Edit Route menu. Then click Show Route, Display Route, and Display Task to visualize both the route and the task. 2. Click the plus icon in the top right corner to add a new task, and set the execution time and the number of runs. 3. Click Enable Current Task. 4. Click Upload and confirm. Then click Refresh, reselect the configured route, and check the corresponding task to complete the setup of the AGV's automatic task. 5. Task implementation. 1. Edit the AGV's route to ensure it follows the correct path. 2. Perform the AGV's initialization setup to inform it of its initial position. 3. Launch the AGV control software, scan the map, and complete the AGV mapping process. 4. Set up the AGV's automatic task to ensure the vehicle can operate autonomously. This lecture ends here. Thank you.